Welcome. In this video, we're going to talk about the relationship between increasing and decreasing intervals and the calculus aspect here, derivatives. So now we already understand at this point what it looks like to have a graph that may be increasing. Essentially, we'll reach a max, and we'll talk more about extrema later. Then decreasing, in this situation, there's a minimum value, and then we turn back around and it is increasing again. So we know what increasing, decreasing, and constant looks like. Constant is just a horizontal line. There is no change. There's no rise or fall. So let's compare what we know about derivatives to this increasing, decreasing, and constant logic. And essentially, the idea here is that we know a derivative represents the slope of the tangent line, right? So when you think about derivatives, derivatives are telling you slope. And essentially, all that this is saying, this test for intervals where the function is increasing or decreasing, lets us know that if the derivative, remember derivative represents slope, if the derivative is greater than 0, that means it's a positive number. And if we have a positive slope, that graph will be increasing. So the second piece says, well, what if the derivative is less than 0? And saying less than 0 means we have a negative slope, or that graph is going to be falling left to right, otherwise known as decreasing. And if the derivative is equal to 0, that means we would have a slope of 0, or the graph would be constant on that interval. We're also going to introduce another vocabulary word here, critical numbers. So you may have also realized, when I talked about that increasing and then decreasing and increasing again, we mentioned there would be a max or a min. And so what we're going to be doing is we're going to be looking to find that max or min value. And the max or the min is going to let us know where we have that change from increasing to decreasing, or vice versa, decreasing to increasing. So the critical numbers, these things that we're going to call critical numbers, they exist in the domain of the function. And essentially the critical numbers are where the derivative is equal to 0 or the derivative does not exist. All right, so if you look to find critical numbers, you are going to be solving to find that c value, which makes the derivative 0, or the c value that would make it not defined, have a value that doesn't exist there. A critical point is that point whose x-coordinate is the critical number. So basically that's just saying if we know the critical number, we can come up with some xy ordered pair, a point on the graph. And we can do that by just taking whatever the c value is that creates the critical number, that value for x of interest, whatever that is, and we're going to plug it back in. All right, so critical numbers occur when the derivative is equal to 0 or when the derivative does not exist. And what we're going to build toward here is that these critical points, that point on the graph, may represent a max or a min. So the critical points are going to tell us that we know there is a change from increasing to decreasing, or we suspect at least that there's a change, and that there may be a max or a min there. So let's define this more formally, and we'll define a test for determining increasing and decreasing. So if we want to determine where a function may be increasing or decreasing, what we're going to do is to locate the critical numbers, and that's going to involve setting that derivative equal to 0 and solving for your x value. Remember also, we want to think about where the derivative is undefined. So setting the derivative equal to 0, finding the x values that make it 0 or the values that make it undefined. And what that does is that creates some intervals for us. So we're going to plot these intervals on a number line, and then we're going to choose values of x on each of the intervals. We're going to call these our test values, and we're going to plug them into the derivative, the value in each interval, and determine if it is positive or negative. And remember, if the derivative is positive, if f prime of x is greater than 0, then that means we're going to know the graph is increasing. And if f prime of x is less than 0, then we will know the graph is decreasing. Let's look at an example. So in this example we're going to look at in this video, we want to determine or find these intervals where the function is either increasing or decreasing. And in order to do that, we're going to use the derivative. So the first thing we want to think about is what type of function this is. And of course, we recognize this as a cubic polynomial. So we always want to be thinking about, is there anywhere that function is not defined? And for a polynomial, of course, we know that the domain for a polynomial is all real numbers. There is no undefined value because there's no denominator or no even root. So we always want to, take that extra thought process into account, because if there's an undefined value in the function, there's likely to also be a similar undefined value in the derivative. So now we'll find the derivative. We'll go ahead and use our shortcut rule, our power rule. So this is 3x squared plus 6x minus 9. This is my derivative. Now my derivative is 1 degree less. It's also a polynomial. It's a quadratic polynomial. And so looking at this, also we would say the domain of the derivative is all real numbers, and that there are no undefined values, okay? If there was an undefined value, we would list that as one of our critical numbers. So I'm going to go ahead and figure out what my other critical numbers are. Those come from taking the derivative and setting it equal to 0. So 3x squared plus 6x minus 9 equal to 0. This, of course, I can factor out a 3. So I have 3 times x squared plus 2x minus 3 equals 0. Divide by 3 on both sides. X squared plus 2x minus 3. 0 divided by 3 is still 0. This factors. I have x plus 3 and x minus 1 equal to 0. And by the zero product principle, I find that my critical numbers are x equals negative 3 and x equals 1. So the only critical numbers I have here are at x equals negative 3 and x equals 1. So what this says we do next is, once we know those critical numbers, we are going to determine some intervals. We're going to put these numbers on a number line and determine intervals. So let me clean up what we're looking at here. So what that means is I'm going to take x equals negative 3 and x equals 1 and plot them here on my number line. Now, when I do that, I've broken this into several intervals. My intervals would be negative infinity to negative 3, negative 3 to positive 1, and 1 to infinity. From here, we want to choose a value on each interval, a test value. It could be any number that we desire. We just want a number that's nice and easy to deal with. So over here on the left, sure, I could choose like negative 10, but a smaller, easier to deal with value to test might be x equals -4. Any number between -3 and 1, I would choose x equals 0. And then on this third interval, greater than 1, I'm going to choose x equals 2. Any number will work. Now, remember what we're trying to do. We are trying to determine where the graph is increasing or decreasing. So that has to do with the slope. Do we have a positive increasing or a negative decreasing slope? Remember, slope comes from the derivative. So I'm going to take my derivative here, f prime of x, and f prime of x, when I factored it, we said that it was equal to 3 times x plus 3, x minus 1. That was what we had on our page. So what would happen if I were to plug -4 in for the derivative? If I put a negative in here, that would be a negative number. This would be a negative number. We'd have -1 and -5 and 3 times a negative times a negative. We would find that f prime of -4 is a positive value. So what does that tell us? If the slope is positive, that means the graph is going up or increasing on that interval. All right, let's look at this again for f prime of 0. So if I take this test value 0 and I plug it into my derivative, 3, 0 plus 3 is a positive number, 3. 0 minus 1, that's a negative number. So we have positive times positive, which is still positive, then times a negative. We've got a negative value here. What that lets me know is we have a slope which is falling from left to right, or a decreasing interval. So let's do this once more. F prime of 2. If I plug in 2, that's 3 times 5, which is positive, times 2 minus 1, which is 1, also positive. And if you're multiplying all positive numbers, you're going to get a positive number here. So positive is going to indicate that this is increasing. We have a slope that is rising from left to right. So you'll notice I I drew some little dotted lines here to kind of divide my intervals. One thing I want to talk about is when I plugged these numbers in, I didn't look at actually writing a number here. All I cared about was whether or not it was positive or negative. And I didn't even calculate what that number is. Since I was considering the derivative in factored form, I just took -4, plugged it in, said that, well, that's a negative number. That's a negative number. Negative times a negative is positive. Multiplying that by 3 will still be positive. And I encourage you to try and do that as well. So we have a positive, and then a negative, and then a positive. The other thing we want to notice here when we think about this is we have plus, minus, plus, and you're going to see a lot of alternation. You're going to see that pattern, increasing, decreasing, increasing, decreasing. Does that mean that's always the way it's going to work? And you can assume that it will work that way. And of course, the answer is no, you cannot assume. All right, so let's think about how I would answer this. Well, considering the fact that these are my x values and these are my intervals, I would say that the function is increasing when I have x values from -infinity to -3, or I should say 1 to infinity. And then we know we are decreasing on that center interval, which is where x is from -3 to 1. So that would be our answer here. If we were stating the intervals where the function was increasing or decreasing, we made this table. We looked at plugging in test values that were on each of the intervals And the intervals were created by dividing that number line using the critical points. We plugged each of those test values into the derivative to look at if the derivative was positive or negative. Positive indicating a positive slope increasing, negative giving us a negative slope or decreasing. And if we look at graphing the originally given function, if we look at graphing it in our calculator, I drew a graph and I decided that's not good enough to deal with, but we get a cubic curve which looks like this. And if we zoom out or we change our graphing calculator around a little bit, we're going to find that we've got some x value here at -3, f of -3. And at next value here, we've got +1, f of 1. And that's where the max and the min are occurring on the graph. And you'll notice that the graph is rising, increasing from -infinity to -3. And then we're also increasing from 1 to infinity. And you'll notice in here between -3 and 1, -3 to 1, that is where our decreasing graph is showing up. So it should connect, it should make sense with what we're looking at on the paper. All right, so you do have that graphing calculator. When you are working on these problems on your homework, do please try to pull your calculator out and look at the picture and make sure that it makes sense to you, because that's going to help you when it comes time to take your test online, because you're allowed to have your calculator there to help. So I hope that makes sense. Basically, most of the problems you're going to do in this section, if they ask about increasing or decreasing or constant, you're going to work through them the same way. Please let me know if you have any questions, because I am here to help. Thanks and have a great day.